Hello everyone. Today we are going to learn about the measures of variability. There is mean deviation and standard deviation. For mean deviation, to calculate for ungrouped data, the formula is sigma xi minus x bar by n, where x bar indicates the mean of the data, and for grouped data, mean deviation is sigma fi into xi minus x bar by sigma fi, where x bar indicates mean of the grouped data. Better than the quartile deviation, mean deviation gives the absolute value. And the other one is standard deviation, which indicates sigma, which the other one is standard deviation. In case of ungrouped data, standard deviation is square root of sigma xi minus x bar whole square by n, where x bar indicates the mean. Similarly, for grouped data, the formula is there. The standard deviation gives most correct value than the other deviations. There are some merits and demerits in calculating the measures of variability. Merits are this: it is less affected by the fluctuations in sampling, hence stable, and it is basis for measuring the coefficient of correlation in sampling. Demerits: it's not easy to understand and it's difficult to calculate, and it is an absolute measure of variability and it cannot be used for the purpose of comparison. And let's take a problem and to see this. Now let's see for the ungrouped data. See, some of the marks of the student were given by 85, 65, 55, and 42, 69, 83, 92, and 77 for an ungrouped data. Now let's calculate the mean of the data by sum of the observations by number of observations, that is 568 by 8, and which gives the mean value as 71. Now calculate sigma of xi minus x bar, which is calculated, see, like x1 minus x bar, which gives 85 first observation minus mean, which gives 14. Like that, we calculate sigma modulus of xi minus x bar, which gives 106 value. And for the calculation of mean deviation, the formula is sigma xi minus x bar by n, which is 106 by 8, which is 13.25. And similarly, we calculate standard deviation. For the standard deviation, we require xi minus x bar whole square by n under root. So we calculate xi minus x bar for every observation and add them using and we calculate them using the formula, standard deviation formula. We get 15.63. Similarly, for the group data, we calculate like that. Right. Even for group data, we calculate mean deviation and standard deviation. See, we have the frequency distribution table with values xi and fi. Now we construct a table with these xi and fi values. We calculate fi xi and we calculate cumulative frequency by adding adding the frequency with the previous frequencies, and sigma xi minus x bar, which we calculate using mean. First, we find x bar and we calculate xi minus x bar. And for the group data, the mean formula is sigma fi xi by n, where n is the number of frequencies, total sum of frequencies, and sigma xi we calculate from the table, and we calculate fi into xi minus x bar. We get this value 140. We divide that with sigma fi, we get the mean deviation, and similarly we calculate xi minus x bar whole square, and with that we calculate fi into xi minus x bar whole square. From that we get the standard deviation with the formula sigma under root sigma fi into xi minus x bar whole square by n, which is 6.69. We calculate for grouped and ungrouped data for the measure of variability. Thank you.